Okay, so today we're going to do a lab where we calculate the speed of sound using some really simple equipment. It's pretty amazing, really. So we're going to use this tube, which I can adjust the length of, okay? And I'm going to use a tuning fork. That's really all I'm going to use to do this. Now I know the tuning fork's frequency. It has a known frequency because the tuning fork is meant to tune a piano, and you want to tune it to a certain note, and that note has a certain frequency, right? A certain pitch, right? And you want to tune it to that, okay? So this is C, and this has a frequency of 512 hertz, okay? And so this thing I can vary the length. So what I'm going to do is I'm going to use this as a resonance tube. Basically, what I'm going to do is lengthen this and decrease the length until I get resonance in the tube. And when I'm getting resonance in the tube, what I've done is I've created a standing wave, okay? And basically, when I make the standing wave, when I get this the right length to create the standing wave, that length will be half the wavelength of the sound that I'm creating, okay? Then I'm going to take the wavelength, the known wavelength from the tube, the frequency from the tuning fork, and I'm going to calculate the velocity of sound, okay? Okay, so first, let's set the scene a bit, okay? So first, I want to make a prediction about what the speed of sound is in this room, okay? So the first thing I do is I pop out a thermometer and I measure the temperature in the room, okay? Now I've already done this, so I know what it is, okay? So the temperature in this room is 23.6 degrees Celsius, okay? Okay, so I know the temperature in the room, and there's a little formula down here, and it's pretty small, so I'm gonna write it larger. And it's V sound equals 331 plus 0.6 times the temperature in Celsius, okay? And this will give you a velocity in meters per second, okay? So if you look at this formula, I want to explain one thing about it that's important. If the temperature goes up, what's going to happen to the velocity of sound? Well, think about it. T goes up, this number gets bigger, this product gets bigger, these two numbers added get bigger, the velocity of sound is going to increase, okay? Now, I'm not going to calculate that for you. You know the temperature. You can substitute it into the equation, and you can get the velocity of sound, the actual velocity of sound in this room. Now, I am going to tell you something else. The speed of sound at 20 degrees C, whoops, I don't want that to be a tiny c, 20 degrees C, in dry air equals 343 meters per second, okay? 343 meters per second. So that gives you an idea. So you should get a number like that from this, okay? Okay, so let's go over and let's do the speed of sound. So first of all, I'm going to use the musical note C, which has a frequency of 512 hertz, okay? Okay, so we're gonna bang this on this pad, okay? And then we're gonna put it in the tube, and then I'm gonna move the tube, the length of the tube, and adjust it until I can hear an increase in amplitude, which means that I'm setting up a resonance frequency, and this is a resonance box. Okay, so let's try it and see how it goes. I think I got it. Let's try one more time. Go ahead and hit it, and we'll try one more time, and I'll make adjustments. Yeah.
Right there?
That's pretty good. Okay, let's stop at that point. Okay, so this is my length. Okay, you noticed if the sound was good on the camera, you probably noticed that you could hear the sound of the tuning fork enhanced by the fact that I set up resonance in this tube. So now I'm going to measure the length of this tube. This length is going to be half a wavelength. Okay, this is going to be half a wavelength. So just measuring this, okay, so this length then is, this length, the tube causing the resonance, is 0.3048 meters. Okay, 3048 meters. So that's half a wavelength. So what you've got to do then is you're going to have to multiply that length of the tube by 2. Okay, 2 times that length, 2 times L, to get the wavelength, lambda. Okay, now you'll have lambda, the wavelength, and I'll write this bigger. The frequency, the velocity equals the frequency times the wavelength. You'll have the frequency here, and you'll have lambda here, the wavelength. You can now calculate the velocity. When you do that, compare that to the velocity you calculated here. How do they relate? They should be close, but they're probably not going to be exactly right. But check on that, okay? So you're going to calculate a velocity of speed of sound with a formula for the room conditions, and then you're going to calculate it with this resonance tube, okay? And compare the two. And then down here, you're going to write why they are different, okay? Because they will be a little bit different. Okay.